Give a holler if you are excited about AI.
Yeah.
And give a good groan if you're in a trepidation. All right, that's fine. Cool. 15 years ago, I was starting my first Ruby on Rails job straight out of college. And I was so excited about everything that was going on. It was kind of like the era of web app development becoming beautiful and the community discovering all these things. I was eating up everything, Ruby rogues and Hacker News and blog posts, and I was so excited. And to be honest, like in the last 10 years or so, that has tapered a lot. We've got a lot more of the same, and it's still been good. But I'm really excited to say I'm there again. Right now, I'm eating up all of the research and reading and attending conferences, and it's really been a fun time. I've spent a lot of hours on that. I don't think that any of us are really worried about being replaced by AI. That's more in the news and other things, but experiencing it firsthand, I think that we realize it's, at least right now, not, you still need someone who knows what they're doing in control. And my take is that will continue to be the case for a good while. And because we see that uninformed vibe code from people who don't know what they're doing, it does not produce quality results that are maintainable. Honestly, this isn't the first time we've seen a shift like this. When they came out with compilers and you could write Fortran, it's basically English. And so they thought maybe this will get rid of the need for all these expensive programmers. Anyway, another worry that is significant is with all these changes to how we're developing, will I still like my job? Because a lot of us really like the craft of building code, and as do I. But I'd ask, like, do you like solving problems for people? You can do that now at an increased pace. Do you like architecting rather than being handed a solution? I think we like that problem-solving phase. And we're still doing that. Are you okay with delegating problems to someone else or like working with a team? We all do that anyway, right? So I really believe that we can make this work for us and still enjoy our work. My take is that right now, as of November 2025, that agentic programming can work very well and produce great results. But it's a skill that you have to develop. There was an old study from early 2025 that stated that allowing AI actually increases the time it takes to complete tasks by 19%, despite engineers thinking it sped them up by 20%. Which was kind of funny. And that was in the era of Sonnet 3.7 and 3.5. So things really have changed a lot with new frontier models being more capable today. But I want to back this up with some data. Google's research department on the state of, they researched the state of AI. And this was over the same period that was studied by that other thing that said we were actually less directed than we thought. They studied over 5,000 engineers from companies from small to megacore. And what they found specifically was that AI speed up has key prerequisites, and Doximity meets all of them. You need a clear communicated AI stance, healthy data ecosystem, AI accessible internal data like Glean, for example, strong version control practices, working with small batches, a user-centric focus, and quality internal platform. Like our Maestro, which is awesome. Anyway, the AI speed up that we can achieve because of those things, because we've done so well in our engineering work, it can create new bottlenecks. And these are usually around code review for creating more code. So we have to optimize those areas and find the bottleneck and work on that and improving it. Usually AI can be applied. And how much speed up on average? I'm not going to go into this in detail, but this is including all the participants who don't necessarily meet those prerequisites. But even overall, individual effectiveness is up 17%. Organizational performance almost 10%, and more software instability. So the ability to recover quickly is key. But there's a big spectrum of how you can work with AI. On the left, you are driving or writing most of the code and maybe delegating some simple or tedious parts to the AI. The second one being kind of pair programming, where you are in charge still, but the AI is driving a lot of the time. Going further, maybe the AI is doing the coding and you're just kind of giving oversight and correction as needed. And then all the way at the end, there's vibe coding, right? Where, well, we all know that vibe coding just produces AI slop, right? But I think we can still vibe and be a little less out of the loop. There's a way you can do that. It's been coined vibe engineering. I like that term. All of these modes can be effective ways of working, and you need to match your style and the task at hand to the mode that you take. So take some experimentation with all of these. Vibe engineering was coined by Simon Willison. If you're going to work in that mode and want to be successful, then you need to employ the software engineering practices that have been serving us well for a long time. So robust automated tests, planning and documentation, good version control, CI/CD, strong manual QA, research skills, having clear specs, managing the agent well, and then judgment about what to outsource to AI. When it comes to, I guess the biggest question that a lot of us want answered is, how do I produce good output from my AI coding tool? And really the only knob, other than changing models, which you can do to affect, the only knob that we have within that model is the context window. We used to say that LLMs are like a junior developer or an intern. You have to kind of tell them everything to do and hold their hand, but I'd say they're not. It's more like Drew Barrymore in 51st Dates, who wakes up every day with no recent memory at all. LLMs are like a remote hire who doesn't know what company they're working for, what the situation is. And it could be they're being asked to write example code for slides, or scrappy throwaway code for a school assignment, or some scrappy scripting, or an early stage startup where only speed matters, or Doximity, or a mega enterprise corporation, or NASA, where any exception, if you don't handle it, costs lives. So without telling the LLM what context it's working in, it won't know, it has to guess. And so, like Adam Sandler had to do every morning and say, this is the context. I like putting something like this at the beginning of my Cloud MD or context configuration for the agent. And I'll read some of it. You are an agent working as or with an engineer of Doximity and reusable, inspired by Basecamp, GitHub, Shopify, and broader Ruby community. We emphasize elegance, simplicity, maintainability, human readable code, and developer empathy. We have these core values, and we are a trusted collaborator, writing maintainable code, supporting healthcare professionals and scarce reliably. And then whatever app you're writing in the code base, you want to include some context about how that fits in and what belongs there. And I've been asked, this looks really vague. Does it actually work? And I think it does. And we just merged this yesterday. But the concept we're familiar with, like if you ask ChatGPT to write in the style of Stephen King, then it does it. It understands that. It's been trained on that, right? And also, our models have been trained on, for example, the blog posts from Basecamp, GitHub, Shopify, etc., and all of their code and these things on public code. and it knows how to act in that environment. So like our LM is really a very senior engineer who just needs to be when it needs to understand the context. But going back to Stephen King, another way you could approach it is to say, write direct and vivid prose, use a conversational tone and realistic dialogue, character-driven narratives, and build suspense through pacing and details, and maybe get similar results to Stephen King, but write in the style of Stephen King can actually probably capture more than you even have thought of yourself, right? So micromanaging our LLMs with lots of little rules might not be the best way to start. Again, this is an experiment that we're trying, and we're going to see the results. But I'm feel good about it. But we'll need to, if we start with a broad directive like this, there will be things that it will miss, and we can add guidance as needed. All right, so all we can control again, other than the model, is the context. And so let's look at the claude/context output. It's important to understand what is in the context window. So at the top here, you see that we have 200,000 tokens to work with, and it's currently 33% full, including the buffer for like compaction. It has the system prompt that tells it what it is as an encoding tool. Tools like, this is how you read a file. You've got your added MCP tools, any custom agents you've created, which is a Claude code feature. The memory files, what that means is like a Claude MD that always gets loaded into every conversation. And then the messages from the actual conversation. So here it's visualizing a lot of blank space here. It's a good conversation. But you can look at this at any point in time and see what's taking up your space. And the context window will vary by model too. So like Codex is 36% larger and some are smaller. And then lower down, you can see what specifically is taking up how many tokens of the whole context window. So the worst things that can happen to your context window in terms of your output is, in this order, incorrect information, missing information, too much noise, and auto compaction, where it summarizes and like loses all the things you've told it that you want to have all the time. Sources of noise or incorrect information can be MCP tools that are not in use. If you add GitHub's MCP tool to your encoding agent, then you have now used 23,000 tokens, and that's 12% of your context window, when there's only 66% that you can use total. So there are some have a take that MCPs were a fad. Some are useful and maybe enable them when you need them. But other sources of noise include a lot of the research, like web searches, that brings in a lot of information. It just has to figure out what's relevant, but it stays in your context window often. Or unsuccessful and vague grepping for trying to figure out where something is in the code base. If you can provide that, then it'll noise up your context window a lot less. Cursor has a superpower in that regard, the semantic search, and I'll talk about that more later. I'd like to get a good org-wide semantic search tool that can pull in precisely the right context from all the repos that we have to efficiently solve the problems we're working on. Because a lot of our efforts aren't just limited to a single code base. Going back, so the best things that can happen for your context window are correctness, completeness. Let's get the small size and intentional phase relevant resets. We'll talk about that last point there. We already do this sort of research, plan, and implement phases as programmers. Maybe they're a little bit more blended when we do it, but it's established. We've established that LLMs do really well with the right information in the context window. And when you're doing research or planning, it can bring in a lot of context that ends up just being noise for the next phase. So doing an intentional compaction or starting a new conversation at that point between these phases can, if you're working on a problem large enough to exhaust the context window, that can be really helpful. And outputs from these could be a functional specification from research. So like what I mean by that is maybe like an extreme product proposal that like takes all the details that were implied from the product proposal and writes them all out, and you can review that with a PM. A technical specification from planning, which might come from your tech proposal or just a functional spec. And AI written code comes from the implementation phase. And without the explicit requirements from these docs, the AI makes guesses about what you want, and often guesses wrong. Usually doesn't ask it. And so instead of reviewing 1,000 lines of code, where understanding all that and making change to all that was harder, you can iterate on the functional spec with your PM, iterate on the technical spec as the engineer, and then it can build without so many assumptions. HIPS right now is experimenting with formalizing the way to approach that, but you can do that informally now, just by doing phases yourself. Let's talk about the strengths of our 4 favorite coding platforms, agentic coding platforms in Doximity. So the first one has been Copilot. It has the reputation, honestly, of being the agentic dev environment that produces the worst output. And some of you have felt that and switched. If it's working for you, that's great, but something else might work better for you. So that's my tip. Cursor is GUI. It was built on VS Code. Before, but now with 2.0, you can switch between an editor mode that you're used to, like VS Code, or an agent mode where the chat takes front and center, and optionally there might be files open on the side. Cursor has the best autocomplete, tab completion. It has semantic search, which I'll talk about more, and a very fast Composer 1 model that's just theirs. Really fast. And if you can use any frontier model with it, it's also a little more expensive than the other ones for the amount of that you get from your subscription. Next is Claude Code. It's really forefront in its agentic capabilities, which we'll walk through. But those are really useful for optimizing the context, which is what we've been talking about. Optimizing usage of the context. Claude models, Sonnet 4.5 is top performing the benchmarks, and you can use it as a CLI or an IE extension for VS Code or Z, which is a good editor for pairing. Last, we have Codex. Codex by OpenAI is very thorough. It has a reputation of producing the most correct outputs, like what you want, and more. It follows your instructions and doesn't forget things that you said as much compared to Claude. And it's also very slow. So you really need to embrace parallel work or embrace waiting. I'm not ready to do that, but just to illustrate that, I said hi to my agent in Codex. And so it explored and read the technology stack and then listed the files and then read a bunch of other stuff from, and it worked for 2.5 minutes until it said, "Hey there, ready when you are." And yes, you are very ready, I can tell. Good job. We might need to tweak our agents.md so that it doesn't say always read this when, just like read this when maybe, because it's but it's that 2.5 minutes, if spending the time to gather the right context can actually be very valuable, which is why it produces better results reportedly. So let's talk about the agentic capabilities. We know that context management is key to good outcomes, and these capabilities help with that. So first, there's the agent config, your CloudMD, AgentsMD, that are ever present in the instructions. They're supported by everything. We've got semantic search, which indexes your whole code base as a vector database so that it can ask natural language English questions about where do I find this, and it brings you the right code. Especially useful for things that are hard to grab for. or as a tech lead, you just want to know like, oh, how is this handled? And it finds the right thing, the relevant code. It's beautiful. And it's only natively supported in Cursor, though it can be added on as an MCP and other tools. Or slash commands. These are where you bring in instructions for a specific task. Like maybe I want to slash review this code or something, and you've got a way that you want to do that. GitHub Copilot lacks these natively, but you can make up your own index of your slash command and say, whenever I type slash something, look this up and go find the right file, load it, learn how to do it. So it's possible. Cloud Code has skills, and it puts the skills short description of what it is for in the context window always. And the agent can choose to bring in instructions for a task when it wants to perform it. So like building a PDF document, and that can be instructions and also executable code to do something deterministically so that when you build a PDF, it's not going to screw it up. We have MCPs, which you probably know about. GitHub is back on the board again with that capability. Just again, be aware of the cost of its instructions in your context window, and please don't use MCPs for anything that a trained model will already know how to do because it's read the internet. So like GitHub, for example, it knows how to use GH. So just have that installed and let it use it. And it doesn't need to take up any space in your context window. Next, we have subagents. This is a Claude Code specific one for now. And you or the agent can delegate tasks to it in a separate context window. So it can go do its research or whatever, and then come back with the results. And only the results are brought into your context window. I've had fun with this. We want to add Docs Analytics to documents, and I thought to experiment. What if we could just do this for the whole repo all at once? So I told Cloud Code, gather all of the pages, and then for each page in a separate parallel subagent, and list all of the things all the actions that a user can take, and come up with a document that a person can review. Do we want to track that? What can we track? And include all the information for the analytic schema JSON that we're going to need to build. So I hit enter on that right before I went to bed, and I said, by the way, when you're done, check the system time. And so it started going, tons of output, and in the morning I came back and I saw that one, it had chosen the cheaper Sonnet Haiku model, no, not Sonnet, Claude Haiku model for the task because it was simple and it didn't need an expensive model, which was really neat to save cost. But also, it only took 7 minutes. So before I even fell asleep, it was done. So that was really powerful. And you can think about parallelism and using subagents if you're using Cloud Code. But the most fun one was DHH is a code reviewer. It says you are to channel DHH, who has a ton of code published online that's very respectable, and blog posts and opinions about how you should approach things in the Rails way. And he will write a scathing review of your code if it's not of the quality standard needed to put in the Rails core, the Rails core code base, right? But not just in a mean way, though it is kind of mean and hilarious to read. Also very constructive, and that's part of its instruction. So like, not this, but this. And it's not always useful, but it can also be very useful when, anyway, plans that Nick and I came up with together pairing, we sent it to THH, and the result that came back, yeah, that's actually a lot of really good ideas that we took. So things have been improved in our quality thanks to that agent. And it's an agent, you can use it as an agent or not, but being in an agent, it can do all of its thinking in a different context window and just write the results of the file. So choose your weapon, right? There are docs policies, you can pick one at a time. Pick one that you think matches your style and try it out for a month and maybe consider trying others. Within Anthropic and Codex, we have API keys instead of subscriptions, so you can swap between those a lot more rapidly than when you don't have a subscription to something else. So earlier we talked about the spectrum from you building things to AI building things. There's also a spectrum from highly specified to very iterative, and each of these are good and valid for different problems and different people and personalities and preferences. Just depending on how you want to work with AI, you can choose different approaches. And if you squint, there is a little bit of alignment between the different tools, the different styles. And obviously, there's a ton of overlap. This is not very accurate. But like the CLI-based tools, Cloud Code and Codex, lean more towards AI writing more code. And Codex's slowness definitely lends itself towards letting it go on its own to do the work while you do something else. I want to walk through some examples in Doximity's app.
And for that, I'll turn it over to Nick.
Hi, everyone. It's Nick Karpenske here from the editorial tooling team, and I wanted to share some information on our LLM setup. So first, if we look here, we've got our LLM instructions stored under docs LLM. We have a couple of folders under here: agents, commands, context, local, rules, and workflows, as well as a couple of regular files. Root context is going to be the first file that an LLM reads. It's currently symlinked out to ClaudeMD and the GitHub and Copilot. GitHub Copilot and Cursor instructions. So this is going to basically tell the LLM where to start and where some files are found that it needs to find. But let's go take a look at how these folders relate to each other. So essentially, we've got a base folder called context that just contains plain statements of fact that the system needs to know to work in. So for example, if we go back to our code here, we will see that under rules, we have rules like architecture. In here, we create a number of rules that say how a system should work. And these rules can be referenced by the LLM to let you know why it made a decision or what it might be violating a condition. These are often referencing the contexts to let the system know if it's given just a rule document that it needs to go read another document for additional information. Next, we've got workflows. And workflows are really where we combine rules and contexts into actionable features of our LLM system. So if we go here again and check it out, we've got some workflows in here around, for example, documentation. What does it take to document a file? What are the types of documents that we want, and what comments that we want, and what don't we want? And it also will reference some of these context files to give a little bit more information about what we're looking for. We have a Git workflow, and this will tell the system what kind of Git commits we want and what they should look like. Again, referencing some context. So these workflows really gather a chunk of meaningful work, or let's say an employee description or a job description, into one place so that we can use them in multiple places. So we go back here, we'll see that those are used by commands, command index.md, which is essentially text shortcuts, and by agents. So if we look in here, let's take a look at commands first. So these are going to be your slash commands. You can type /DHH or /PR, /QCheck. You'll notice many of these Q prefixed commands are from Sabrina Romanov's Git workflow, or sorry, LLM workflow. But we've added some of our own in here. And these are essentially just commands that will reach out to workflow documents. We put all of this information in workflow documents so that it's not captured directly in the command. Next, we've got our command index. The command index is basically shortcuts for any LLM that does not allow native / commands. So this will let the system know that if you ever type one of these weird words, QUX, it knows what that means. It's referenced somewhere. It knows to go to a workflow and start running that, although it'll usually run that in its own parent agent process, not in a sub-agent. This command index serves solely to support Copilot, which does not support native / commands. There's a directive in the root context that tells it to look into this document if it ever sees what it believes is a / command. And then finally, we do have agents themselves. For example, we have a code quality enforcer that will go through and look for any code quality issues. Looks like we need to move some of this documentation into a workflow. In fact, it looks like many of these will need to be moved into workflows, but this is an example of one that's already been moved into a workflow. So test writing in JavaScript should always refer to the test writing workflow. And it should also refer to these rules. So this gives a little bit more context to the agents so that they know what to do, considering that they're opening with a fairly blank context window. So that leaves just the local folder. The local folder is available for you to make personalized changes to your LLM setup that you don't want committed to the repo, or to try new things before you put them in the repo to make sure that they work. It's all get ignored, so you can do anything you want in local, and it just won't affect other developers on your team. So hopefully that provides a decent overview of our directory structure, and we hope you enjoy using it, and let us know if you have any feedback for us, because we are constantly iterating on this.
Yes, thank you, Nick. These are for inspiration and not necessarily the best way to do everything, because we don't know the best way to do things, but we want to try stuff and see what works, and I want you all to do the same. We're supporting a lot of different coding agents. And so we created, instead of creating this file and copying it to agentsmd and claudemd and GitHub instructions, we created it in the docs folder with everything else. We use symlinks to just symlink all those files to here, and symlinks to rules and cursor, / commands, put everything in the right place for the agents, because they haven't standardized and probably never will. The symlinks are your friend there. So having seen all that, I read this blog post the other day. It's Peter Steinberger, and I was really struck by him. He says, over time, we started maybe with vibe coding, just like, oh, fix this problem. We're kind of uninformed about how to work with AI as we're newbies and get poor results, right? And so then we go into this higher complexity curve about having 8 agents at the same time and complex working and orchestration, multi-checkouts, and maybe like a little bit of what you just saw here in our doc example, with a lot of / commands and all these rules and lots of files. It is complex, and well, that's true. So, and then he says over time, at least from his experience, he tends to now keep it a little more simple. Grab a screenshot of what you're working on, which is actually really useful to finding the right code. And saying, hey, look at these files, providing the right context. And then do this medium-sized change. We're still the engineer in charge, but we can reduce the complexity. All these are valid, and it might be anywhere on that spectrum, depending on what you want to do. In the end, to answer the question, how do I get quality AI-generated code? We have a lot of tools here, but to sum it up, be aware of and manage your context. You want to get the right information in your context without the noise and misleading information. Use your agent's capabilities to help with them. Match the model strengths to the task at hand. And experiment with that. And then try using the research plan and implement phases. Maybe the new conversation or compacting to remove the noise. And then keep experimenting. So what's next? For AI, we don't really know. We can expect more change. That's what's next from AI. For me, I'm working on bringing in the right context via org-wide semantic search, looking for the right tool to do that. Unblocked is one that I'm looking at that I think is very promising. And I'm also looking for an approach or the right tooling to share agent instructions so that we don't have to copy paste these out. There's a tool called Pacmind that's open source that acts as a version repository for these kind of things that I would like to evaluate. Or maybe we just have GitHub repo. And for all of us, know that engineering with AI is a skill. It's some things you try will fail, just learn and get better. Keep going. Experiment with the agent instructions and share what works, kind of doesn't. Experiment with different styles from tab completion to vibing. Experiment with different approaches, like or the approaches to research, planning, and implement phases. And learn how to collaborate with AI to resolve the code review bottleneck that we're going to experience more and more. Because AI is really good. AI review is really good at finding certain classes of problems with code. And I don't know if we all really understand what it's good at yet. We've got to figure that out and then take and delegate that to AI. And when we review code, we need to look at the things that it's not necessarily good at. And for a while, that's going to take us reviewing everything and looking at AI code reviews and seeing what it catches, seeing what it misses. We can develop an intuition for that over time. So anyway, keep doing the things
In review that humans are best at. I'd recommend listening to the Ruby AI podcast. Our former Valentino runs that and does an amazing job. And also the Ruby AI Builders Discord has been great if you're interested in connecting with more people and seeing kind of what's happening, people's experiences on the forefront of Ruby AI development. And last,
I think the future is not scary for us as engineers at Doximity. With Doximity embracing AI development, big transitions like this have happened before, not just with the compiler and whatnot, but like the Industrial Revolution. We move on and find a good place in it. I think it's going to be good. You're still going to be the engineer solving problems, building the solution. You've got new tools to do it. You got to learn how, but it's kind of a fun game getting better at things. Okay? And this is one of those. I think you can have a lot of fun with it. It's kind of the new craft. Even if you're not crafting code, you can craft how you approach coming up with excellent solutions using AI as a partner. So will you like it? I think that you can probably find a lot to like. Let's just open it up since we only have a few minutes. Whatever thoughts you have, then I can ask specific questions. Yeah.
Yeah, just say that iterating on this has been very fun. It's definitely increased my productivity. It makes it easier to do things like, well, the AI is working, you go do some code reviews or, do some research on something. No reviews. Yeah, it's been very, very beneficial. I've seen my productivity significantly over the past like 2 months or so that we've been really pushing that. So, and it's fun to iterate on. Just make it know like the team is going to be very involved in making tiny changes. And then occasionally those changes will show up in PRs and you can try to pull those out into separate PRs if you want. So it's easier to merge it quick so that your change is reflected in other work that you're doing. Like if you need to switch branches, it's much better to have that change on master right away. But yeah, just make small everyday changes and discuss it with your team. Do retros and stuff.
Yes, thank you. Then. All right. What other thoughts do y'all have? What's been working for y'all? We're struggling. Yeah, go ahead.
Thank you for sharing all those configurations that we could do with all the agentic agents. I'm I mostly use GitHub Copilot, so I haven't used those things yet. But yeah, like after the presentation, I feel like using some of those and then I get to experiment with the cursor and the stuff. So yeah, I just felt like okay, there is a lot that has happened in the last few months. Yeah, that I missed. I think I need to catch up. It's pretty great.
Yeah, thanks, Kartik. I agree. Like there's there's so much to learn, and it's not, I don't think it's going to stop, right? We are continually developing new approaches and finding what's working and figuring out as a community what's been good and what's working for us, right? So I think that's why it's especially good now to be involved in the community and looking out for things like that. How much time do we have?
None.
Okay, well, thank you so much.